In question 3, we are given a shaded region with the curve of equation 1 by 4x times 3 minus x. It's rotated through 2 pi radians about the x-axis, so like this. And we have to form a solid. This will form a solid shape like this. So this black shaded shape, it will be like a birthday hat. We are given the volume of this shape would be 2 by 5 pi, and we have to show that the x coordinate of the center of mass of this shape will be 31 by 24. So if we start, we have to note that for a rotation about x-axis like this about of 2 pi radians, we'll have this formula where x bar is the x coordinate of the center of mass. So we can write m as rho v because rho equals to m by v. So m equals to rho v. So we'll get we can take a rho common outside here because this is a constant. So we'll get pi rho times the integration of x times 1 by 4 3 minus x whole square. We can cut out the rho on both sides. We'll put the value of v over here. V is 2 by 5 pi. On the right side we get this equation. We can cancel out the pi's. Now we can write this. We can expand 3 minus x whole square. We'll get 9 minus 6x plus x square, and from this we'll get x cubed by 16. So if we continue our calculation, we can take the 1 by 16 outside the integration, and we'll be left with this term over here, 9x cubed minus 6x to the power 4 plus x to the power 5. We have to integrate this now. So if we move the 2 by 5 over here and divided it with from 1 by 16, so 1 by 16 divided by 2 by 5, we'll get 5 by 32, and if we integrate inside, we'll get 9x to the power 4 by 4 minus 6x to the power 5 by 5 plus x to the power 6 by 6. Now we'll put the limits of 2 to 0 because this value is 2 and this is 0. So we'll get 5 by 32 into 124 by 15, which will be 31 by 24, which we have to show. Now in part B, we are given that the solid is now placed with its circular face on a rough plane. So the circular face would be this side over here. It's kept on a rough plane which is inclined at an angle, so it's basically kept on a ramp like this. We are given that the plane is sufficiently rough enough to prevent S from sliding and that it is on the point of toppling. So we have to find alpha, the angle of the ramp. So this. If you look at a diagram like this, this would be the ramp. So this would be the scenario over here. This will be alpha. This is 90 degrees. So this will be 90 minus alpha. If this is 90 minus alpha, this angle will also be 90 minus alpha. And this angle over here will be alpha. So if we visualize this, this is the center of gravity. This is how it acts. for the shape to be on the point of toppling, the line of action of weight needs to act through the edge of the material. So this edge, this, if the angle of the ramp was increased slightly further, the object would topple. So if this was the case, it would be something like this. So the object would topple like this. So in this case, the weight will act through this line. We know that this distance, this is basically the x coordinate of the center of gravity of the shape. So we know this from part A, which is 31 by 24. So this is 31 by 24. The whole of the length is 2. So this, if this is 31 by 24, this section over here will be 2 minus 31 by 24 or 17 by 24. So this section will be 17 by 24. This would be the value of y at x equals to 2. Basically this is x equals to 2 and this is x equals to 0. If we match it with the shape above, this is x equals to 0, this is x equals to 2. So we need to find the radius, this. So this is basically the value of y when x equals to 2. So value of y when x equals to 2, when x is 2, y is 1 by 4 times x times 3 minus x. So half. So we can just put in half over here. Now if we match it with this diagram, this angle over here will be 90 minus alpha and this angle will be alpha. So if we write tan alpha, let me separate the triangle over here. This is the triangle, this is alpha, this is 17 by 24 and this is half. So tan alpha would be the opposite, which is half. So half divided by 17 by 24. For alpha we'll get tan inverse, so we'll get 12 by 17 over here. So tan inverse 12 by 17 would be 35.2 degrees. Do we have any conditions? No, we don't have any conditions like to the nearest degree or 1 decimal plus, so I'll just keep it in 3SF. So that's it for question number 3.